Hey everyone, so I'm Thibault working at Cloudflare, and today we're going to talk about the evolution of privacy pairs. And I really want to insist on the evolution. Privacy pairs is a 6-year-old protocol and has changed quite a bit over the course of its history, and I really want to highlight a bit how it's changed and what lessons we can learn from that. And so the first question I have for you is if you can raise your hand if you're a human. Okay, we have a good consensus. Not everyone seems to be human. Not sure why. Okay, but if you can raise your hand, are you human again? Is it going to have less people, more people? I'm not sure. If people are not sure, I'm not sure how that happens. Once again, raise your hand. Are you human? Okay, there's more consensus. That's great. It's great, and at the same time, it's super bad, because that's the experience that some people got when browsing the web, just because of situations that they cannot handle. They have a bad IP reputation. Maybe they're using a VPN. Maybe they're just using a device or some accessibility settings that just prevents website from correctly identifying them as and allowing them through. And so that's one of the problems that privacy pairs try to solve. And today we're going to talk a bit about the history of privacy pairs, how it has been built and how it has evolved, then the real-world deployments, and finally what and where we would see it evolve next. So first of all, the history. I will do a quick reminder of what is a web request. At a high level, you have a user which has a client, so it could be a web browser. It can be it's mobile phone, Chrome, Firefox, whatsoever. And it will request a resource from an origin. So I don't know, you're looking for kitten pictures, and so you will go to a kitten picture website, and the website will return you the kitten pictures. It's slightly more complex than that, because if you take it from the point of view of the origin, this looks like a cloud, but it's more of a fog, because the origin don't really have the user next to them. It's just a computer sitting somewhere. And so what they will see is they will see an IP address. They might see a user agent. They might have the timing of the request and all kind of metadata associated to the user. And so they construct some pictures of what this user is. And this is even more prevalent now that you will have some new privacy preserving protocols. So I don't know, a user might browse the web using Tor, and so they would have a Tor exit node IP address. They might be using a VPN. They might be using I don't know, MASQUE or HTTP. And so the factors that some origin we're relying on, such as IP address, which is very good because it provides you location, provides you some reputations, etc., might not have scaled and evolved in the way that would be respect and privacy for users, and allow the origin to make a decision to prevent I don't know, spam or bots, etc. Lots of bots want to access cat pictures. And that's where privacy pass comes in. If you want one bit of information, you would use privacy pass. And how would you do that? The user would go to the client and say, hey, go to the web browser and say, I want a cat website. The browser would go to the origin and say, hey, I want the cat website, the cat picture. And it would not get it first. The origin say, the request might look suspicious, or I would like to have some more guarantees that you're not trying to I don't know, DOS me or abuse the resources that I'm providing. And so instead of returning the cat picture, the origin would say, okay, please do one more check. Check that you're human, check that you have one more are able to solve a specific challenge. To solve this challenge, the origin will usually embed a third-party code. Should it be a CAPTCHA? Should it be some auto verification? And that's what we call the attester and the issuer. The attester and the issuer will try to attest that the fact that the user meets certain criteria, and so there will be some back and forth between the attester issuer and the client to ensure that the user meets and matches some property. Once that's done, we go back to the client, and finally we present the origin with the solution. And that's what happens here. You go, the user, via the client, redeem certain tokens that it got from the attester, and the origin is able to verify that the token comes from the attester, but it's not able to actually see which challenge method has been used, Was it like a certain captcha provider? Was it age verification? Was it IP reputation? We don't know. And that's the initial setup for privacy pass. There's some limitation because like as the attester and the issuer will provide some token, this token might be like stolen by like other website, or maybe you can like gather like a huge amount of tokens and like spend them all at once against an origin. And so that would prevent like also a DOS factor. And that's where the IETF design comes in. We have both a separation between attester and issuer, so that the issuer is not able to see which request you're making. So it doesn't see like the IP, it doesn't see the content header. You can like really strip a lot of information. And in addition, the protocol became interactive. So what happens is like, instead of like storing token on the client side, every time an origin will ask for a new challenge, you will have to go to an attester which will issue you a token via the issuer. If we take a more, like, I don't know, engineering diagram work, the full flow is like when a user tries to like request content, we'll go to the origin will say, I will need to authenticate you. Privacy pass is an authentication protocol, therefore sending back like a ... authenticate header. The client, upon seeing this authentication header, will like say, okay, so I cannot get the request right now, but I know what to do in order to like get it. So it will it will request and interact with an attester so that the user is able to solve a challenge. When the challenge is solved, the attester goes to the issuer, requests the tokens, and then we go like all the way back. The issuer gets the token, the attester gives the token to the client can give the token to the origin, and then we get the kitten pictures back to the client. If we try to like crystallize a bit of like the evolution that happened for the protocol, we would like have like the first release in 2017, and then various like events that happened. So like we publish a paper, there's been like a new cryptographic primitive with VOPRFs that's allowed like some more private and like easier key rotation in the addition of like additional providers. Then the IETF group got created and like more people got on board. There's been like the release at like a wider scale with like private access tokens by Apple. And finally this year, we just like tested some post-quantum experiments in addition to like update the code base and possibly an RFC, but we'll see how that goes. Now that we have like set up the protocol, we would like to like better understand exactly like who's using it, how, and like what are the metrics. And so if you would like to take a like high-level look at like what is who's using Privacy Pass, or at least like based on the first version, it's quite versatile in terms of like the number of people and companies that like have tried to use it. Could be for like various use cases. So like we've mentioned abuse prevention is one of the example, but it could also be for like private advertising with like Facebook private stat. Could be with contact tracing, such as like what Norway did. Prepaid services, such as like a secure storage with list authority, and also reward scheme with bad attestation tokens. In terms of like exactly compliant with like the standard, which is like rather new because it's only 2 years old, we have the deployment of Apple with private access tokens. And so it allows Apple to do some like abuse prevention on their private relay servers. The idea of private relay is that every user that has private relay enabled will relay the HTTP traffic through the providers. And so every user of an Apple device with private relay enabled will be on a limited set of IPs. And therefore, you will need to change the way that like you detect and interact users, and Privacy Pass was deemed to be a good solution to do that in a privacy-preserving manner. If we look specifically at metrics for private access tokens, it's been super good. In terms of like the reduction of like the number of challenges, we had like 92% less challenge served to user. And even on the challenges that are being served, if you are able to provide a private access token, you have like 42%, you are 42% more likely to pass this challenge. In addition, the time that users spend solving a challenge has been reduced drastically by like and divided by half. So overall, it's been like very successful rollout. In addition, if we look at like a more researchy experiment, which is a Privacy Pass extension, and it's the first extension that got rolled out. We still have like 500,000 downloads on like both Chrome and Firefox. And we have two attestation methods in the form of like HCAPTCHA and Cloudflare turnstile. They do provide interactive and non-interactive method to solve a challenge. The extension is a bit outdated. Like the latest update of the protocol has been in 2019, and we're definitely looking forward in terms of like upgrading it so it supports the latest version of the protocol. So we have a full view of the protocol, some metrics, and so what can we expect next? First thing we can expect is kind of like extend the usage of privacy pass on the web as a kind of like single bit, zero knowledge proof, and lightweight protocol to prove certain statements. In order to do that, we released 2 weeks ago a privacy pass library, which is used in JavaScript and which is like compliant with the latest draft. As you can see on the screen, we just like took some comments directly from like the like draft RFC and like inline the exact method that like you would use. This implementation is like open, so like anyone can use it. And it has been designed to like abstract the cryptographic primitive so that you don't need to know what is like blind RSA, what is VOPRF. But at the same time, we expose some protocol agility. So we won't enforce any like specific challenge method, or if you want to do like some like interactive or non-interactive challenges, but you will be able to use that for like multiple use cases. If we try to see how privacy pass has evolved, I took a slide from Nick Sullivan's presentation in 2019, and he mentioned like a couple of statements of like, where should we have been and move next? 4 years later, where are we? So he mentioned like a lot of things, and like one of the things was it needs to be integrated with more CAPTCHA providers. So we now have 2 CAPTCHA providers supporting privacy pass. In addition, if we want to explore like some post-quantum VOPRF and some post-quantum privacy pass, we've done that. And similar for like VOPRF submitted to CFRG, it has been standardized and published as an RFC. There's been a few ideas that haven't been explored yet, and so I tried to revisit like this slide to see like where like in 2023, where do we go next? One of the things is like a public implementation of all the components. So I mentioned that like Apple and like Google, for instance, were using some sort of like privacy pass, but like these components are mostly proprietary and like closed source. And so one of the things like we would be working on for anyone and to allow some like more diversity of attestation is to open some component that like people could play with. In addition, we're bringing a new API so that people can have a single bit like knowledge sharing. But are we really removing IP as a way to like identify user? That's like one thing we're trying to like work out at Cloudflare. How can we like really less rely on IP and just have like a single bit of information which is more scoped to the need that we have? Finally, some like platform integration is important. So I mentioned Privacy Pass is an extension on the web, and it's also like implemented on iOS and macOS. And really this integration should be as open as possible. So for instance, the like Chrome web browser and like Firefox all have like a way to like register an authentication. And these have been like designed a while back and only support basic authentication. It would be good to support like new kind of authentication protocol, such as Privacy Pass. In addition, being able to handle user preference, should it be in terms of like the various attestation that like they would like to do, some accessibility for challenges, etc., is also very important. And this might need some kind of like governance or federation in order to understand which kind of like attestation are privacy preserving. How could we like make that more private in the future? And that's it. Thank you.